Hello, you are watching Y tutorial with Raja sir. पुष्पा झुकेगा नहीं सारा मेथड सीखेगा. This is the question number 38 from EC Verma. This is the question number 38 from EC Verma. Discussing third method for this question. So how can we solve these questions? Okay, so find the current through the 10 ohm resistor shown in the figure. So we are trying to find the current through the 10 ohm resistor. So if we know the voltage of A and B, then we can easily use the formula of actually we can use easily the voltage rule, and we can solve this problem. How can we find out the EMF or voltage between A and B? Actually, we can simplify this diagram as say, suppose this is a point A. We are writing it right side A. So in between that two there is a 6 ohm resistor, and this but an A cell having a EMF 0 ohm. Okay, for the above portion it is very easy. This is the 10 ohm and the another battery is connected. This is the 3 volt. Okay, similarly the lower portions has 3 ohm resistors that is simultaneously connected with a battery that that has a EMF 4.5 volt. So now we can apply the combined formula of, so if we want to represent this equivalent combination of battery into a single cell having some resistance, that means we are using parallel cell combination formula. That is EMF equivalent and this is the resistance equivalent. What is the resistance equivalent? 1 by resistance equivalent 1 by 10 plus 1 by 6 plus 1 by 3. How much is it? Is so R equivalent equal to, so inverse to the power minus 1, so 10 6 3 LCM is 30, so 3 5 10, so R equivalent is 30 by 18. So R equivalent is 5 by 3. And what is the equivalent EMF? Equivalent EMF equal to E1. So you know equivalent EMF E1 by R1 plus E2 by R2, E3 by R3 into R equivalent. So this is the formula equivalent. So here suppose you taking the E1 equal to 3 by 10 plus 0 by 6 plus 4.5 by 3 into R equivalent. So 3 by 10 equal to 0.3 plus 0 plus 1.5, and R equivalent is how much? 5 by 3. So this is 1.8 into 5 by 3. So how much? 0.6 into 5, that is equal to 3. So equivalent EMF for the whole 3 combined battery having some resistance in a parallel combination is 3-fold. So E equivalent equal to 3-fold and R equivalent equal to, so how much? 5 by 3 ohm. But from AB there is no external current. Okay, so what is the voltage? So from this whole combination, no current going outside, I equal to 0. So VAB should be how much? So you know VAB equal to E equivalent minus IR. Okay, if some current is flowing combinedly, so E equivalent minus IR, so I is 0 for that case from the whole circuit. So there is no external current. Okay, so minus I into R equivalent, so this portion is 0, so there is no out I net that is going outside, so E equivalent equal to the voltage. Okay, VAB equal to how much? 3 volt. So actually, so if we combine this upper loop, sorry, upper portion, in that case, the we if we apply this formula, so from the if we formula, so in that case that is very easy. So again 3 volt minus 10I, if some I current is flowing, 10I, 3 minus 10I equal to VAB. Yes or not? Okay, okay, 3 actually, if going that direction, okay, so voltage from B to 3 volt increases, and then again due to current flow some voltage decreases. Okay, so that's why 10I equal to how much? So we are getting this. So suppose you are taking this I1, so I1 equal to how much? 0. So we can write, okay, like this way we can find current flow for each and every branch. Okay, you can, okay, we can check this. Okay, best. Okay, so this is I1, this is I2, this is I3. Okay, but we need only I1, but for checking purpose we will find the I1, I2 and I3 for each component of the current. Okay, so from B point to, so VB plus 3 volt. Okay, so we know now from B volt if increases. Okay, so from VB, okay, plus C, if you go from B to C, then how much voltage increases? 3 volt increases. Then due to current flow, how much voltage changes? Actually in that case from C to, when we go A point, in that case voltage decreases. How much? IR. So I1 into 10, that is equal to VA. So if you write this, 3 minus 10 I1 equal to VA minus VB, so that is equal to VAB. So similarly, if we solve this thing, in that case we are getting I1 equal to how much? 0, because VAB, we find that VAB equal to, from the equivalent battery circuit combinations, we find that VAB equal to 3 volt. Okay, and for the second um, second register, we can count VAB equal to how much? 0 volt minus 6I2. So VAB equal to 3 volt, 6I2. So I2 equal to how much? Minus 0.5. So that means the current is flowing for that resistor from right, from right, left side to right side direction. Okay, for third register, okay, so VAB equal to how much? 4.5 volt minus how much? 3I3. So 3 equal to 4.5 minus 3I3. So 3I3 equal to 4.5 minus 3. So in that case I3 equal to 3I3 equal to 1.5, I3 equal to 0.5 ampere. So that means in the above circuit I equal to 0, that means no current is flowing, only current is flowing for that loop, the lower loop. The current is flowing, how much current? 0.5 ampere current is flowing. So 0.5 ampere current is flowing from 4.5 volt cell or battery, and that is circulating in a lower loop, this lower loop. Okay, I am taking this. So how much? 0.5 volt, and in that for I2 the current is not flowing that direction. Actually we are getting the negative value, that means current is flowing opposite direction. So this is the loop. Okay, so in that loop, in the above loop current flow is 0.